Today we are going to discuss about ETL pipelines for sales data warehouse, where in the world of data engineering, ETL pipelines are essential for collecting, processing, and storing data from various resources. The rapidly evolving landscape of e-commerce business generate vast amounts of transactional and customer-related data every day. To extract valuable insights from this data, it is essential to consolidate it into a centralized system designed for analytics and reporting. This centralized system is called data warehouse. Today, we will discuss on ETL pipelines for an e-commerce sales data warehouses that is responsible for efficiently handling and preparing sales-related data from multiple resources, such as order processing systems, product catalogs, and customer databases, and loading it into a structured data warehouse that follows a star schema design. Firstly, what is data warehouse? A decision support database that is maintained separately from the organization's operational database. Support information processing by providing a solid platform of consolidated historical data for analysis. It is, for example, the organizations have their databases, but they store the data which is uh, we can say like recent data. But whereas warehouse, we uh, in warehouse uh, it it stores historical data for analysis, whereas recent means it will be updated for uh, um, um, it will be updated for some amount of time, like uh, for 4 months, quarterly, or 1 year, or half a year. Likewise, why a sales data warehouse? A sales data warehouse centralizes all sales related data, enabling better decision making, forecasting, and performance tracking. By storing clean, transformed data in a structured format, analysts can run complex queries without impacting production systems. ETL. ETL is extraction, transformation, and loading. These three processes combinedly called as ETL pipeline. The process of uh, processing these three are called pipeline. Firstly, data extraction. Get data from multiple heterogeneous and external sources. Then it's sent to data cleaning, detects errors in the data and rectify them when possible. Data transformation. Convert data from host format to warehouse format, then loads, sort, summarize, consolidate, compute views, check integrity, and build indices and partitions. This then it it goes to refresh where the updated data is again stored in the warehouse, propagates the updates from the data sources to the warehouse. We go in detail where ETL pipeline overview. Data source. Uh, we retrieved from the fake store API, where a publicly available API that simulates e-commerce sales. Ingestion. The ingestion.py script automates data extraction from the API. Raw JavaScript notations. Data is saved in the raw dictionary, preserving the original structure of the sources. These are the raw files which are stored. Um, After processing, we get these CSV files while processing. Uh, Transformation of data. The transformation.py cleans and normalizes the ingested JavaScript data. Key transforms include flattened nested JavaScript fields, ensuring consistent data types for analytical readiness, generating processed CSV files stored in process libraries. Then it gets to load. The process data in CSV files will be loaded for further processing and solve the queries required. We do EDA for understanding the structure and distribution of the data, identify missing or inconsistent values, detect duplicates or outliers, gain insights to guide the data cleaning and information. We detail see here when when we get the process data from the warehouse, we do exploratory data analysis to understand the structure and distribution of how the data is done and to rectify the errors in the data and get insights. Firstly, we load the data sets as this, and these are some functions, EDF functions, where DF head, where we can see the top five reports and info about the specific data set and description, the columns, missing values means the null values in the specific data set. How many null values are there in the specific and the shape of the data? These are the data sets. For the cards data set, we get these card ID and card date. These are the top five. This is the info. This is the description where the count, main, and there are no missing values in this data set. When we come to products data, this is the shape of the data, 7 2. When we come to the products data, top five are these. This is the info. We have attributes like product ID, price, product name, description, image URL. Likewise, we does to all the five data sets. Finally, we check once again where to don't have the null values. There are no null values in this. This is your EDA processing. The proprietary SQL database follows a star schema design, optimizing the data for analytical queries and OLAP operations, where the fact tables we have our sales fact table, holds transactional data for all sales activities in the data. Dimension tables are user dimension, product dimension, categorical dimension, and card dimension. We have four dimensions. We can see here, this is the fact table where we have product ID as primary key and user ID, card ID, and category ID as foreign keys, where the three are in other dimension tables. Sales ID, quantity purchase, and those. When we goes to category dimension, we have category ID and category name and cart dimension. Here we can see here in user dimension, we can um, summarize this into two names. We can summarize this and replace as half, where we can keep city or zip code. We can keep zip code as one ID, and we can form another dimensional table here. This is the star schema diagram of these data sets. Mm, Coming to the insights we get, these are the top five products by total sales revenue, where the product name and description and total revenue. Based on the total revenue, we got the insights here. Top customers by total spending. We get top customers by their spending, who got highest spent top five customers. Then total sale revenue, total sale revenue by product category. Means based on their category, how much revenue they got, total revenue, total sales revenue by product category. And coming to conclusion, the insights generated from these data warehouse have provided a clear view of the top performing products, valuable customers, and revenue distributing across the categories. This information is crucial for making informed business decisions and identifying potential growth areas in the e-commerce sales domain. When coming to the revenue distribution by product category, what categories they can sell more? Coming men's clothing, they can keep extra clothing in their, what do you say, e-commerce office. They can keep extra clothing there, and they can reduce women's clothing to not to go into losses. Coming to here, uh, he if he comes again, we can keep any discounts to him by giving for this amount, this much discount, because he is spending so much on us. So we can give some discount. He can come again. By this, we can get insights mm, and we can grow the business by these data analyze by analyzing these data by ETL pipelines. The insights generated from these data warehouse have provided a clear view so that we can grow our business. Thank you.